Hi, everyone. This is Rich Berliner from Digital Locations, and I'm very pleased this morning to have Elias Alwan from FIU, Florida International University, with me today. And I'm going to let him do the introduction to talk a little bit about his background. But I want to thank you for being with us today, Elias. And uh, I just wanted to really kind of have everyone else that we're talking to understand a bit about you, what you're doing, your background, and why we're so excited about working with FIU on this project of satellite to mobile communication. So, without further ado, Elias, tell us about you and what you've done and your background.
Thank you, Rich, for the nice introduction. So, my background, I'm originally from Lebanon. So, I did my bachelor degree at Notre Dame University in Lebanon. And then I did a master's degree at the American University of Beirut. Then I moved to the United States and I did my PhD at the Ohio State University at the Electroscience Lab. It's one of the most let's say, advanced lab and famous lab in doing research in electromagnetics, and and then I moved to FIU as a professor here. So since then, my research has been focused on ultra wideband systems. That include designing wideband antennas, wideband radios, RF system, RF front ends, um, and communication systems. Um, I focused my research in the past few years on the millimeter wave bands that go up to the W band, which means up to 115 gigahertz. And also recently, I started introducing machine learning and designing RF systems, a very interesting topic. And uh, now I have a team at FIU that includes 10 PhD students, and I'm very proud of them.
Good. So, we are really excited about working with you, FIU, and your team. I'm doing an interview with Arjuna, who's also on your team tomorrow. And one of the important aspects and why we chose FIU, because we did have the opportunity to work with other universities, but we chose FIU because I think your skills and the resources you have at FIU on the antenna side, on having the proper equipment to do the testing that we need, I think it was very impressive, and that's why we chose to work with you. One of the important aspects of this is why is this even something that we're doing research on in terms of the problem of satellite to mobile communications? We've heard anecdotally about companies that are doing short messaging and companies that have, and I say this tongue in cheek, that have represented that they've, achieved phone calling and those sorts of things. But, we're looking at doing high speed data from satellites to your phone. Why is this something that we need to do this kind of intensive research?
Exactly. This is a very difficult problem, as you just mentioned. Now, when you say doing high-speed data from satellite to phone, it's acceptable. But the real difficult problem is when you say doing high-speed data from phone to satellite, and this is really where our challenge is, and this is what we're trying to tackle in this project with you. The objective of this project is to enable this high-speed communication between a cell phone, uh, regular cell phone, directly to satellite. And this is very important, especially in areas where connection to a base station cannot be established, let's say in the middle of the ocean or in places where really we don't have that connection. So connecting directly to a satellite will be very important and can save lives if if needed. Um, so why this is a difficult problem? Because in order to establish any connection, you have to have a link, a closed link. And to close the link, you need to have enough transmit power, enough receive power, and enough data rate. Usually, the longer the distance, the harder it is to establish the link, and the slower your communication should be in order to close that link. So, how can we play with all these variables in order to allow or close that link between your cell phone and and the satellite? Now, what we're focused on in this project is first, what can we change on the cell phone side to enable that link to happen, to close that link, to enable that communication? Um, and and as a next step, what can we do at the satellite level? Now, most of the competitors today in the market, without mentioning names, they worked on the satellite level. Our project is more focused on at the first step. The first step is at the cell phone level. So, what can we do on the cell phone level to enable that link?
Right. So we're talking about, if I understand this correctly, we're talking about we've got hard problems, hard things to solve, hard problems to solve on the uplink and the downlink portion of this. And so we're looking at, I assume in your research, you're looking at frequency, power levels, and all sorts of other component level items that go along with this to create that link and hold on to that link for high-speed data. Am I close on that? Am I right?
You're actually very correct. And we are limited. So there are, for example, if I can pump power from my phone as much as I want, yes, I can establish this communication very easy, but I'm limited to a certain level that is allowed by the FCC. So I have to respect those limits. So what can we do with that limited power? So our system is power limited. With a power limited system, what can we do to establish that link? So the power variable is not there. So, and what other people are doing today is slowing down the communication to compensate for that low power. To slowing down the communication means you can only send short messages.
Right. I've done some interviews recently with folks from other universities for our interview series here, our podcast, talking about the effects of weather, talking about the effects of space dust, talking about all sorts of satellite issues. And so it seems like this is got to be, our project has to be the mastery of all of the different elements that go into making this work and work in harmony so that we can not only have the link, but we can have high speed data. And so we're really excited about that. Tell us more about your approach to this. Is there anything that without giving anything away here, excuse me, is there anything?
Yeah, all these factors that you just mentioned actually, they would only attenuate our signal, and they will only make our problem even harder. So, what can we do to avoid all these problems that do not occur every day? For example, if you have rain, or if it's snowing, or there are other weather factors, they happen once in a while. So your system, the way we're thinking about it, your system needs to be adaptive enough to change its configuration based on any new situation. And this is where we are creating some form of intelligence in the system that will allow it to switch to different frequency band and play with its parameters dynamically to make sure that we can always achieve a high-speed link.
Gotcha.
In any kind of condition.
Good. Well, we are really excited about this project and about working with you and your team. And so I'm really hopeful that what we can do is show the way towards a future where everyone on Earth has the ability to have high-speed data and improve their lives, improve their safety, and all the things that go into it. So, Elias, go forward, make us proud. Let's get our research going in the most efficient and speedy way we can to get this done. And I'm sure there are going to be a lot of challenges for you, but that's why we've chosen to work with you and your team to solve the hard problem of satellite to mobile communications.
Thank you so much. And I'm very excited about the project, and I'm confident that FIU and the labs that we have at FIU, they are the right place to accomplish this mission. As you mentioned before, we do have, we're well equipped. We do have measurement equipment that can characterize any system from low frequency up to the terahertz frequencies. So you are working with the right team.
Thank you. I think so too. And thank you for being with us today and doing this. And we will talk again soon. I'm going to, as I said, I'm going to work with your colleague Arjuna tomorrow. And then from there, I think what we'll do is we'll do another one with the both of you who are leading this team together in the future. But thank you again. I hope to see you in person very soon down in Miami, and we'll talk again on a future podcast. Thanks, Elias. Good talking.